What's up, Recessians? Addison here. I thought I'd just share a little direct instruction content with you to engage your curious minds and to give you more mathematical stuff to chew on before our next cohort. So I want to introduce you guys to the fundamental theory of algebra, which I think can be said as this. So first of all, in algebra, we start seeing these letters in math, which spook a lot of us out because they're not numbers. And so you might ask, why even have a letter in the first place? And there's two reasons. The first reason is that it could represent a number that we don't know yet. So an unknown number. That's a good reason why we might use a variable. And by the way, you could use an x. You could also use a smiley face. It just takes a little longer to write. But it's the same basic idea. You could even use a box or any sort of symbol to represent an unknown number. There is another reason why you'd use a symbol, and that's to create a variable number, which means that the number is not the same. It actually can vary. In some situations, like the situation y equals 3x, x and y here can actually be any number in the universe. It just is the case that y is 3 times as much as x. So those are the two reasons why you'd use variables in the first place. Okay, now I want to introduce you to what I call the fundamental theory of algebra, which is that if you have an algebraic equation, for example, here let's come up with a very simple algebraic equation, x equals 2. Okay, so x here is representing an unknown number, but then equals 2 goes ahead and tells us what x is. So this looks more like the solution to an algebra problem than per se a question. But we're going to use this to build and to practice with the fundamental theory of algebra. So what is the fundamental theory of algebra? Okay, let's say it. You can do whatever you want to an algebraic equation as long as you do the same thing to both sides of the equation. So I'm going to go ahead and turn the equal sign into an equals line to make it very clear that we have a right side and a left side. And the equal sign tells us they have the same value. Now I can do whatever I want. So I'm going to multiply both sides by 2. I'm going to use a dot. In algebra, we start using a dot to represent multiplication as to not be confused with the x variable rather than using an x. So I could multiply both these sides by 2, and I would end up with 2x is equal to 4. Notice, let's experiment and see if this is true. Is this expression the same as the one that we started with? Well, if I were to replace x here with a 2, I would get 2 times 2 is equal to 4. And sure enough, 2 times 2 is 4, and 4 does equal 4. So we can see that this premise of doing something, in this case multiplying by 2, to both sides of the equation doesn't break the fundamental sense of the mathematical process here. Now I can continue to do stuff. For example, let's say I wanted to subtract 3 from both sides of the equation. I could do so, and I would end up with 2x minus 3 is equal to 4 minus 3. And notice that 4 minus 3 is 1. Now if I wanted to, I could divide both sides by 4. And while I can't simplify them, I would end up with this fraction here is equal to this fraction here. Then I could subtract 2 from both of these fractions, and I would end up with 2x minus 3 divided by 4 minus 2 is equal to 1/4 minus 2. Now I might say 1/4 minus, and now change 2 to have a common denominator with 1/4. And so 1/4 minus 8/4 would be negative 7/4. Okay? So that's the fundamental theory of algebra. Now, we're actually doing it backwards. We're going from the answer, x equals 2, into an algebraic problem, this complicated, messy looking thing with fractions that we see at the bottom. But I'm doing this to introduce you guys to the fundamental theory here. So now let's use that same fundamental theory to work this problem the other way around. So let's start at this creation here. And we know, since we just made this based off of the answer that x equals 2, that if we do our algebra correctly here, we should get to the answer x is equal to 2. So another principle of algebra, there's actually an infinite number of ways to break down this problem and to solve for it. And so as mathematicians, we're always looking for the simplest, most efficient way to do so. So we could add 2 to both sides. That might be helpful. But probably the easiest thing to do here to untangle this equation and get it back in the form x equals something, that's what we're looking for, right? the cleverest thing to do might be to multiply both sides by 4. So now when I do so, this is another important detail. I need to make sure to multiply the entire sides by 4. So I'm going to put parentheses around the left side because it has multiple components to represent that I'm multiplying the entire thing by 4. Over here on the right side, I'm going to go ahead and multiply that by 4. Now the reason that I want to do that is that it's going to eliminate all the fractions in one move. So for example, when we divide a number by 4 and then when we multiply that same number by 4, those are opposite operations that are going to end up canceling out. Likewise, when I distribute this 4 into my parentheses and I multiply 2x minus 3 divided by 4, again, the 4's will cancel out. When I multiply 4 by negative 2, there is no divided by 4 to cancel out, so that'll end up getting negative 8. But that's okay because it's not a fraction. So what I'll have is 2x minus 3 minus 8 is equal to negative 7. Notice that this looks a little bit different than the path that we used to make the problem in the first place. But as long as we're abiding by the fundamental premise of algebra, you can do whatever you want to an equation as long as you do the same thing to both sides. And what we do otherwise abides by the laws of mathematics and makes sense, then we should arrive at the answer x equals 2. All right, let's find out. I'm excited. So now, actually, we don't need to do any algebra per se. We can do something called combining like terms on the left side of the equation. We have two numbers. They are like in the sense that they are just numbers with no variables in them. And we can go ahead and combine those to find 2x minus 11 is equal to negative 7. Negative 3 minus 8 is negative 11. All right, now, eventually I'm going to want to get rid of that 2 in front of the x. But here's another technical point when it comes to solving these algebra equations. In order to get rid of that 2 in front of the x, I'm going to need to divide by 2. But if I do so now, I'll have some gross fractions like negative 11 halves and negative 7 halves. And 2 doesn't divide evenly into 11 or 7. So that will make my life, that will work. You could do it that way, but it will make my life slightly more difficult than it need be. So instead, I'm going to deal with that at negative 11 first, and I'm going to combine it with that negative 7. Now, I can't combine them directly because they're on different sides of the equation, but what I can do is add 11 to both sides. That's a clever move because negative 11 plus 11 is nothing. So I'm able to eliminate that negative 11, get it out of the way so that I have only 2x remaining on the left side. Meanwhile, on the right side, negative 7 plus 11, by the way, the order of addition doesn't matter, so negative 7 plus 11 is the same thing as 11 plus negative 7, or simply 11 minus 7. You might find that to be a little bit easier, and the answer is 4. So now, sure enough, I can do my final step and get rid of this times 2. By the way, I was just working with a student, and we discovered that when you have a number next to a variable, what operation is connecting this number here to this letter? And the answer is when there's no operation shown, multiplication is implied. So now I want to do the opposite of times 2 in order to untangle this equation. And so I'm going to divide by 2. That will cancel out my times 2. If I make something twice as big and then I make something half as big, I'll be right back to where I started at x. So I have x here is equal to 4 divided by 2, and I can fit two 2's into a 4. So voila, I've arrived at x equals 2, just like that. So this is a basic introduction to the fundamental theory of algebra. You can do whatever you want to an equation as long as you do the same thing to both sides. So let's take a look at that in one more problem, and then I've attached a few more problems to the end of this video for you guys to investigate on your own and see what you come up with. So let's take a look at, I'm going to make this one up as we go. 3 times x minus 4 plus x is equal to 11 minus 2x. All right, let's give this a try. Now, there's no guarantee here, as we do a problem like this, that we will get a whole number answer. So the answer might be a fraction, which would be exciting. Hard to tell. Let's find out. So another principle that comes up as we solve these algebraic equations is the idea of the order of operations. I know a lot of you are coders, so this is somewhat similar to that the first line of your code happens before the 27th line of your code, right? And that order is irrelevant. So same in mathematics, we need to do our operations in a set order. We can't for example, add this x and this x just yet. And the guiding principle that tells us what order we should do the mathematical operations in is PEMDAS. Parentheses, exponents, multiplication and division, and addition and subtraction happen in that order. So the first thing we need to deal with is this set of parentheses here. Now, when we have a number and there's no operation stated between the number and the next symbol, then multiplication is implied, as we learned earlier. So we have a times 3 here. Now, the key is that everything in this parentheses set is getting multiplied by 3. So we call this distribution. I like to draw little arrows to show who's getting multiplied by 3. It's kind of like a party favor. If you go to a birthday and you give out party favors, you got to give one to everybody, right? Otherwise, they're going to be upset. So same goes here when we distribute the 3. Everybody needs to get a times 3 inside those parentheses. So we end up with 3 times x is 3x, and 3 times negative 4 is negative 12. Then I'm simply going to write down the rest of the equation since nothing happened over there. Plus x equals 11 minus 2x. Okay? Now, similarly, I have an opportunity to combine like terms, which I always want to take when I have it. So I don't have to do anything to either side of the equation in order to start to untangle this and make it simpler. I can simply combine 3x's here with 1x. Now, a good analogy is that if you have 3 footballs and you get another football, how many footballs will you have? And the answer is 4 footballs. So 3x plus x is 4x, much in the same way as 3 footballs plus another football is 4 footballs. So we end up with 4x minus 12 is equal to 11 minus 2x. Now I have some options on how I want to handle this. I'm going to go ahead. I would like to combine the numbers with the numbers. This is another principle of algebra. You want to combine the numbers with the numbers and the letters with the letters. Now I can't do that at the moment directly because they're on different sides of my equation. But what I can do is I can add 12 to both sides. Oops. Let's correct that. Add 12 to both sides. There we go. The reason I want to do that is negative 12 plus 12 is nothing. Those cancel out. So I'm left with 4x is equal to 23, 11 plus 12 minus 2x. Okay, now I'm getting closer. If we review where we started to where we're trying to get to x equals some number, we can see that we are starting to untangle our headphones and get a little bit closer to where we're trying to go. So now I've got all the numbers together on one side of the equation. That's a good sign. The next step is to get all the letters together on the other side of the equation. So notice that all the numbers there without letters are nicely grouped. Now I need to group the x's together. Now, in order to do that, I'll have to eliminate the x's on this side. To do that, I need to do the opposite of minus 2x. The opposite of subtraction is addition. So I'm going to go ahead and add 2x to both sides. That cancels out my negative 2x. On the left, I have 4x plus 2x is equal to 6x. So now I have 6x is equal to 23. So looks like if you can see ahead one step, we're going to end up with a fractional answer, which is fun. So now in order to eliminate times x, remember if there's no sign, no operator between a number and a letter, then multiplication is implied. So we have 6 times x here. So I'm going to do the opposite of multiplication, which is division, in order to cancel out that times 6. And I'm left with x is equal to 23 over 6. Now 23 over 6 is a perfectly good way of representing an answer. It's called an improper fraction. Now if I wanted to represent that as a mixed number, I could. 6 goes into 23 3 times with a remainder of 5/6. So I could also represent the answer as 3 5/6. Okay, that's a little overview in just 2 problems of the fundamental premise of algebra and a lot of the particular details that come up when you try to solve for an unknown variable in these type of situations. This is a great thing to learn because it is the backbone and foundation of virtually all higher mathematics and quite a bit of science. So I hope you enjoyed this video. If you did, let me know. If you didn't, let me know and give me some feedback. Always trying to make these better. And I challenge you to solve the 10 algebra problems that are attached to this video on your own. Happy mathing, and I hope to hear from you soon.